Okay, in this video, again, we're going to continue learning how to graph quadratic functions in standard form. You'll notice, again, that we still have our ax squared part from section 8.1. Today, we're going to add on the c value in our quadratic function. So, first of all, we should keep in mind and recall that a controls whether the function has a stretch or a shrink, and it also controls x reflection. So that is not going to change as we progress through this section. Now, c is the next one that they add into what we're doing because c is very simple. If c is positive, it's going to shift your graph up however many units. If c is negative, it's going to shift your graph down. So you can see here in your notes that it says c is greater than 0, it's going to move your parabola up. C is less than 0, it's going to move your parabola down. C does not have any control on stretch or shrink. C does not have any change on your axis of symmetry. It can move your vertex because it can shift it up and down. And in turn, that will affect our range sometimes. So we'll have to keep an eye on that. So the example here, they're just saying that g of x is equal to x squared minus 2. So what we would do with our table of values from our parent graph that we keep using, again, it's -2, -1, 0, 1, and 2. Our outputs were 4, 1, 0, 1, and 4. What we would do with all these values for our new function g is we would simply subtract 2. So if I subtract 2, I get 2, -1, -2, -1, and 2 for my new outputs. So when I go to graph my new function, again, my parent function I'll do here in blue. So here's my parent function. This new function with g of x equals x squared minus 2 is simply going to take all of those points and shift them down 2 units. So there's no stretch or shrink. There is a transformation 2 units down. So my transformation is 2 units down. Okay, my axis of symmetry, though, again, we said is not going to change. So my axis of symmetry is still x equals 0. My vertex changed because, again, I shifted down 2. So instead of 0, 0, on this problem, it's going to be 0, -2. And what you'll learn about c is that every time we have a c value, that's actually going to be what's called our y-intercept. And again, what we did with graphing lines the other day in our warm-up, we should know what a y-intercept is. It's where the graph crosses the y-axis. C is always going to give us the y-intercept. Again, domain is all reals. And our range this time is going to be y is greater than or equal to -2. Okay, so on this one, again, take some time, get some graph paper, but you should be able to tell me the transformation just by looking at these values and be able to identify what changes in your domain and range and all those things up above. So take some time and try these. Okay, so the graph on x squared minus 5, again, -5 is going to be our y-intercept. So it's going to start here. And then as we plug in our points and we shift, it should go like this. Again, everything should be the same except for, so my domain is still all reals. My range is going to change to y is greater than or equal to -5. Okay, transformation was 5 units down. Okay, and then again, we want to identify axis of symmetry and vertex. So a of s was x equals 0. Vertex was 0, -5. Okay, we should be able to answer all those questions on every one of these problems. The next one, again, a of s is going to be 0 still. Our vertex this time should be at 0, 3. So I'm going to go ahead and plot 0, 3. Again, there was no stretch or shrink. It was just x squared. So I just took my parent graph values and I shifted them up 3. So again, domain stays the same. Range this time is y is greater than or equal to positive 3. And the transformation is 3 units up. Okay, so now what they're going to start to do is they're going to start to change the a value and the c value. So as you can see here, we have 4x squared plus 1. Now what I always tell kids to do is take a couple values and then plot their reflection. So again, I know my axis of symmetry is going to be at 0. I know this value is positive 1, so I plot positive 1 on my y-intercept, and I know my axis of symmetry is 0. So if I take, for instance, the value 1 and I plug it into my function, I'm going to say 4 times 1 squared plus 1. So 1 squared is 1 times 4 is 4 plus 1 is 5. So at 1, my output is already up at 5. And then I can plot the reflection. Whoops, let's undo that. I can plot the reflection over on this side. Now again, by the time I plug in 2, odds are it's probably not going to fit on my graph already because I'm multiplying by 4. But our domain, range, transformations, all those things we should still be able to answer. So let's start with A of S. Again, A and C don't move anything left or right. So every time today, my axis of symmetry should still be 0. Vertex should be 0, comma, and again, I look to my C value because that's my y-intercept. It's going to be 0, 1. Okay, my domain is all reals, so I'm just going to put all reals. My range this time is going to be y is greater than or equal to 1. And my transformations, okay, so here's where we can start to add to it. We had a vertical stretch by a factor of 4, and we moved up 1 from where the original parent function would be. So our original parent function, if we were to graph it, I'll do it in blue here, should kind of look like this. And as we can see, we have a stretch and we're moved up from that original point. So again, take some time. Oh, this isn't the practice yet, sorry. So on this one, what they're doing is they're telling us that we're going to change g of x based on what it says in the previous function. So if it just says the function f of x minus 7, I'm just going to take my function f of x and I'm going to subtract 7. Well, in this case, all I'm going to do is move this function down 7. So my new function g of x, I should be able to write it as negative 0.5x. And instead of plus 2, I subtract 7 from that and I get minus 5. So the transformation from f to g on this one, you guys, is just down 7. So it's not comparing it to our parent graph, it's comparing it to the prior graph and saying, what will this transformation do? So don't worry about the graph of these so much. You wouldn't have to graph these on the test or the quiz, but we need to understand what that means there in terms of the transformation. Okay, so again, take some time, pause, try to graph these, especially these first two, and then you can just tell me what the transformation is on number 5. So a rough sketch of number 3, and again, if I plug in 1 on number 3, it's going to be able to give us a nice value. So I'm choosing 1 because it's next to our axis of symmetry. So 1 squared is 1, times 2 is 2, minus 5 is going to be negative 3. So when I plug 1 into my function, again at 0, I'm at negative 5. So I'm clear down here, and then at 1, I'm down at negative 3, and then I can plot the reflection. So my rough sketch of my graph should kind of look like this. My domain is all reals. My range is going to be y is greater than or equal to negative 5. My transformations is a vertical stretch by 2 and down 5. My A of S was 0. And then my vertex was 0, comma, -5. Okay, again, we can answer those questions on the next one too. So h of x, now instead of plugging in 1 this time, because my denominator is 4, I'm actually going to plug in 2 when I go to plug in a value. So that'll help me find a nice easy number that comes out of it. So at -1/4, I'm going to plug in 2, because when I square 2, I end up getting 4. So I have -1/4 times 4 plus 4. -1/4 times 4 is just -1 plus 4 is equal to 3. So when I plug in 2, I get 3 out. Now before I even graph this thing, just based on what I'm looking at, again, my A of S should be x equals 0. My vertex should be 0, comma, 4. Okay, now my transformations, what I should be able to identify, I have a negative sign out front, so I know I have an x reflection. I have 1/4, so it's a vertical shrink by a factor of 1/4. And then I have plus 4, so it's going to move it up 4. So my sketch of my graph, before I did anything, I already knew my axis of symmetry and vertex. My vertex should have been there. When I plugged in 2, I got 3 out. So at 2, I'm only down this much, and then the reflection should be about right there. So we should be able to have a pretty good idea of what our picture looks like before we put anything down on the graph paper. Number 5, you can just tell me on the test, this moves it up 3. Okay, so again, that's kind of the gist of the lesson, you guys. I want to keep the video short for you. Now, when you get to some zeros of a function problem, understand this is what we did last chapter. When it's asking for the zeros, you're trying to find and solve for when your function equals 0. So in this example, we have -16t squared plus 64. Now what we can do is we can factor a -1 out, and this is actually now going to be the difference of perfect squares. And again, I'll help kind of guide you guys on that path. But if we look at this, these are perfect squares. I could have even factored out a -16 actually. So let's do that. Let's factor out a -16, and I'm left with t squared minus 4. So if I factor this, it's going to be t plus 2 and t minus 2. So I have two solutions here at 2 and -2. Okay, so that's what it means when it says to find the zeros. It simply means to solve. Okay, again, make sure you guys are asking questions, working out examples, rewatching parts of the video. But here's what we were supposed to have accomplished and be able to understand for the day. Thanks, guys. Have a great day.